So in this video, it's going to be a very short video. I'm just going to talk mostly about surface area and surface of revolution. We're going to get to the examples in another video. So what I wanted to go ahead and mention to you was what a surface of revolution is. So it's kind of like a solid of revolution, only I'm not worried about the inside. So basically, again, take a curve, any curve you want. I'll draw that curve. Okay, so there's my curve. What I'm going to do is I'm going to revolve it around a line, an axis. In this case, I'll do the x-axis just because of the way the curve is. And so I'm going to revolve this curve around, and it's going to come down and it's going to kind of look something like that. Maybe not exactly that, but, close enough. And so what we're doing is we're revolving this curve around, and again, let me repeat, we're not worried about the inside of what's contained inside this curve. I'm just looking around at what the edge of the curve is going to look like as we revolve it around. So in this case, we're no longer looking at the volume, we're going to start looking at the area. Remember, volume is a three-dimensional measure, so we're looking at all of the contents inside of this three-dimensional solid. But in this case, I'm looking at surfaces, I'm looking at area, so I'm only worried about 2 dimensions. And so instead of looking more like a volume formula, it's actually going to look more like the arc length formula we just did in the last lesson. So here's what I'm going to do. I'm going to go ahead and, again, since I mentioned it's a curve, usually a rectifiable curve, so something that's continuous and differentiable, rotated around a line, rotated around some axis. I'm going to go ahead and write down the surface area formula. I'll call it SA for surface area. And what it's going to be another integration from A to B, and it's going to look a little different. So what I want to make sure I mention is we're talking about here 2 times pi times, I'm going to call it the radius. Now, I want to make sure that you guys understand it's an important thing, it's an important distinction that when I'm talking about the radius, we're talking about it either in terms of x or in terms of y. And it's going to look a little different than when we did the shell method. It's going to be kind of similar, but not exactly the same. And I'll kind of get to that more in the examples. But so we're going to do a radius in terms of x or y. And what I'm also going to do is go ahead and multiply by that function's arc length, okay? So that's essentially describing the height. So it's 2 times pi times r times the height. So it's essentially finding the surface area of a cylinder. If you were to do it in terms of y, it's going to look pretty similar. It's just we're going to do r of y, and this will be 1 plus f of y. So again, you can do it in terms of x or y, and here's actually the best part about this. It doesn't really matter on most of these whether we're revolving around the x-axis or the y-axis, because in this case what we're doing is we're finding areas. So again, we're not worried about some of those extra dimensional stuff. So if we're revolving around x-axis, you can use either one. If we're revolving around the y-axis, you can use either one. The difference here is how difficult the problem is going to get. So sometimes the problems are really difficult using x's, and it's easier with y's. And sometimes the vice versa is true. Sometimes it's easier with y's, and sometimes it's harder with x's. So it's going to be one of those things of when you start getting into the problem, just kind of think about it and say, hey, is this difficult? Is this easy? Am I doing this kind of the right way? So like I said, this is what we're going to do. We're going to use these formulas in just a second. I'm going to come back with some examples in just a minute.